All right, well, welcome everyone. Before I start, who here has either known about RxJava or has worked with RxJava in the past? Cool, so we have some people here. So before I get into the nitty-gritty, just a little shout out. I'm currently working for a company called Unomi. We basically take all of your smart devices and we put it into one centralized hub. There are just a few of the products we support. Right now, we don't use RxJava in our app because I just started working with them 2 weeks ago. But if you look at the now versus the future updates, you're going to see some huge performance improvements as well as the reactiveness of RxJava. So I'm really excited to get that in there. But now for the big thing that everyone's waiting for. RxJava. So what is it? This is the definition by the guys who made RxJava. You can find it on the wiki. But to sum it all up, it's basically an observable pattern where you have listeners who you say, hey, I want to grab this information. Let me know when you get it. And then the observer will then shoot out that information to everyone subscribed. And that is it in the nutshell. As many of you might have heard, RxJava 2 is out, and I highly recommend using it. There are a lot of issues with RxJava 1. One of the big ones being overflow with back pressure. Right now in RxJava 1, you kind of have to manually do it. Sometimes you can get lucky and it'll do it for you, but RxJava 2, this has been addressed as one of the main concerns. So what can you use RxJava for? Those are just a few examples. Network calls being my absolute favorite. You can pair it with retrofit, so you can have retrofit be your network handler where you'll get the information and you can pass it through RxJava and you get this nice observable object where you can then pass it on to the rest of your app, to anyone listening, and all that glory. There's also a library called RxView made by Jake Warren. It allows you to basically use RxJava with views. So right now you can do on-click listener, you can use butter knives, annotation to do it, or you can use RxJava where, let's say you have a edit text view where you want to check someone's password, but you don't want to start listening for that information until they've entered at least 4 characters or whatever the min is. You can set that kind of information in RxJava so it won't even start listening until that minimum's set, and then you can even put a pressure on it where don't send me too much, stop the input limit at a certain amount, so that way you always get the latest and greatest at the rate you want, and you have full control over that. But we'll get into more of that as we start talking about the individual objects. One big thing I do need to clarify now, because this is a very big thing in RxJava, is hot versus cold. So in RxJava, hot means that as soon as you create your observable, it is going to start doing the work. It doesn't care if there are people listening. It's just going to start turning and start churning and start shooting out information regardless if anyone's listening. Cold, on the other hand, will only do the work once it has at least one subscriber. And if you unsubscribe at all, it will stop working. Well, not stop doing the work instead. So that's the big one for hot and cold. But now the big one that everyone's probably wondering, what the hell is an observable? So these are just a few of the methods of how to create an observable. For people who have worked with RxJava, you will notice the create is on the top. That is, in RxJava 2, the create function now works as intended and you can use it. You will have control over your observable. You can emit as necessary and you don't have to worry about all the issues with RxJava 1 where it was kind of iffy on if it really did what it wanted to do. The .just method will allow you to send one object. So say you have maybe a user you want to pass in. You can just say, hey, observable.just, here's my user, and now it's in the stream for the data consumption. Likewise, array and iterable just let you pass in a list, an array, anything that you can iterate, you can pass through it. Callable is very interesting where it's pretty much like an async. If you have something that might take a moment, you can use that. Same thing with from publisher where your information might take a moment and you want to just kind of wait till it's done and then shoot it off. You can use it for that. Great examples is if you ever had to use the Facebook login, you would notice they have their own custom interface where you say, hey Facebook, I want to log in, then you have to use their listener to get the information called back. With RxJava, you can put a wrapper around that, and now you have control over when you're actually getting that login, and you can pass it into your observable stream. So here are one of the functions you can use in observable for, and it's called map. Very simple. You just say .map. All the rest of the code will be auto-populated with a function. Object 1 is what you're passing in. Object 2 is what you're expecting to pass out. So say you pass in a user, and maybe you want to return back an employee instead. This is one of the methods you can use. It will handle, as you can see, exceptions. Unlike RxJava 1, if you throw an exception, it was kind of hit or miss of what's going to happen. Here, if an exception gets thrown, it will get thrown to the on error of your subscriber. So whoever is listening will get that error guaranteed, and there's no worries for losing that. The next one, this is where things get a little bit crazy, is ConcatMap. So what this will allow you to do is it will force order. So if you want to do an operation from A to Z, it will do A first, wait until A is done, and then move on to B. Likewise, the format is very similar where object 1 is what you're passing in. And then if you'll notice in object 2, it's wrapped around this observable source. That is because ConcatMap expects a observable to be returned as the end result. So let's say you wanted to pass in this user object, and let's say you want to get some more information. Maybe you want to get the guy's car, bank information, who knows what. You can then create another observable to say, hey, observable, go grab this guy's car information. And when you get it back, go ahead and put it into the user and return that back. So it gives you, again, that control with the stream. And again, if you get an exception, it's all taken care of for you. FlatMap. This is one of my absolute favorites because it does not care about order. If you have 100 API calls that you need to make, this will make 100 threads for you. You can limit how many threads are made for this call. It's just an override of FlatMap. You just, after the function, you just do comma and then what that number is. So you can limit it to 3, 4, 5, whatever you prefer. But if you have, let's say, a bunch of API calls for different users and such, this is a great one to use because it will grab it for you and you don't have to wait for it, but it will spit out one object at a time as it receives it. Let me know if I'm going too quick. I know this is a lot to get wrapped around, but I do have Android Studio installed on my laptop, so I'm more than willing to show examples afterwards of like how easy it is and how a lot of this stuff is pre-populated for you. And with lambdas coming up, all this boilerplate disappears and it becomes from 6 lines of code to about 3. And it's much easier to read and it's a lot nicer to look at. But moving on, zip is another personal favorite of mine. So what zip does is it allows you to take multiple observables, n number of observables, you can pass in as many as you like, and then it would say, hey, only let me know when this information is ready when everyone has emitted something. So say you have, let's go back to our user example where you want to get the guy's bank information, car information, and some other information about our user. You can then say, hey, here's our user, but I need to grab all his information. So you can make your API calls to the bank API, the car API, maybe his house API, whatever you like. And then when you grab all that information, bring it all back to me. Let me manage how I want to put it back together. And if you see in object 3, that is your output. So you can then say, okay, I'm taking all my objects, all my information, I'm combining them, and now here is the final result. One of the big issues with Android is, especially when you have to deal with multiple APIs, you have this issue of like race conditions. You make 5 API calls, then I got to check, okay, who's come first, who's come second, did all my calls make it through, can I continue forward? The zip function handles that all for you, and you never have to worry about that. You are guaranteed all your objects at the same time. You can even do some really fanciness where, say if this is a hot one, you can say just give me the latest versus because sometimes maybe you have an observable that might spit out more information than the other one, so you can kind of just always grab the latest and wrap them all together. All right, so how the hell do I get my information through all these methods and observables and all this shenanigans? All you have to do is you just say, after you've made your observable, you've created your workflow, you just say, hey, .subscribe. Here you'll see I'm using a observer, which will give you the on next, on error, on complete, as well as when someone gets subscribed if you want to do anything fancy with that. I recommend when you're starting off, don't mess with that. It's more of an advanced thing to do, but you can do some really cool things. But you don't even need to do it like this. There's also consumers where you can say, hey, I just care about the information. I don't care about the exceptions. Maybe someone else is listening for it. Let them handle it. Give me my data. And all you have to do is just say, instead of new observer, you just say new consumer, what your final output will be, and then it will pre-populate with just a apply method of that object. And that's it. All right, now we're getting to the RxJava 2 model of Flowable. So as I was mentioning before, one of the biggest issues with RxJava 1 is the back pressure. In RxJava 2, observables no longer have back pressure. It's completely removed. If you want that, you have to use a Flowable. Yes?
Could you expand on what you mean by back pressure?
Yeah, so back pressure is, say you have a sensor that's spitting out, point every 10 milliseconds, but you only want to know the information every 1 second. So that observable is going to be spitting out, data point every 10 milliseconds, but you're telling it, wait, I only want 1 point per every second. So you're going to have this back pressure where things start building up, and then RxJava kind of freaks out and goes, whoa, there's all this extra information. What am I supposed to do with it? In RxJava 1, it doesn't know how to handle it correctly. In RxJava 2, you can tell it how you want to handle it. So buffer will say, oh, if you ever get that situation, just buffer some time and it'll eventually go through. It's got ones where it'll drop anything that is going too quickly. And there's a few others I'm still learning as RxJava. It literally just came out this weekend. So there's a lot to learn still, and there's all these cool methods. The other nice thing is everything I just showed you with the observable class also applies for Flowable. So you get the same create method, the same just, from, as well as the FlatMap, ConcatMap, and zip. Is that good for you? Cool. And if you're wondering what this emitter is, so as I was mentioning before, in the .create, it wasn't really handled correctly, but now you'll have this emitter that will say, that will have the .onNext command on complete as well as on error. So if you want to create your own observable or flowable, you have the complete control using the .create call. Transformers. These are kind of an interesting one. I'm still learning these as I go. The biggest one I use is I get a little lazy and I kind of want to do my .subscribe and .observe on. And what those are is, so you can tell RxJava for the .onSubscribe on where you want to look. Do you want to put this on the I/O thread? Do you want to put this on a new thread? Do you want to put this on a computation thread? Do you want to execute this immediately? You can tell that to RxJava by saying any observable, any flowable, hey, I want you to subscribe on, and then you specify the thread. The observe on states who you want people to be listening for. So say you have an I/O call, but you want Android's main thread to start messing it once the data is here. You just say, hey, RxJava, go ahead and observe on the main thread, so that way when I have data, I can populate my text view and show it correctly while the app crashing, saying, hey, you're not allowed to touch this. But here is just a static method, or just a regular method where you can create, where you can say, hey, I'm going to pass in this object, I'm going to spit out this object, I just want you to apply the I/O thread for me so I don't forget how to do this. And then all you have to do is you go to your observable and you just say .compose, and then you just say apply I/O once you've created this method. Mm-hmm.
So the subscribe on and observe on, why do they need to run on different threads?
They don't have to. This is just an example I use very often where I will do a network call and then I want to take that object and immediately apply it onto the UI thread. So say like I get a user, I want to display his first name, last name, maybe he's got a picture URL I want to display. If you don't specify that, Android will yell at you saying, hey, you're not allowed to touch this, it has to be on the original thread.
Right.
So RxJava will do this for you in the back end.
And the subscribe on, like, is it like totally continuously looking at the data that's coming in?
Yep. So once you've used the subscribe on, all observables from that point forward will always be on that thread. So once you've subscribed it to the IO thread, any observable that you've chained into this flow would be on that IO thread.
Then what happens on the observe on thread? Like what exactly does it do? Like, does it communicate with that thread? Or?
Yeah, so it acts like a layer, so Android can like look at the objects and not crash because it's on a separate thread besides the UI. So like sometimes, let's say you want to access the text view directly because you want to say text view dot set text. By saying observe on the on complete call or on the on next when you get your objects, you can directly reference the text view without the app crashing. Because if you ever notice when you do like an async task or anything that's async, if you try to access the UI thread without saying like run on UI, it's going to crash because it's like you're not allowed to do that. It has to be on the original thread. So that's what that does. Mm-hmm. Can you test RxJava for unit tests? Yes. It is the most easiest thing. I almost didn't believe it at first. All you have to say is after you've made your flow is .test. And then after that, you just say, hey, I want to insert my results, and this is what I expect it to be. That's it.
Is that .test new in 2.0?
Yep. That's why I didn't believe it. I'm like, no, this can't be. But it is. I've even done a couple tests to just like try it, and yeah, it's as easy as that. So if you have any workflows, you can always test them. You're always guaranteed the results. I think this was a big thing with the reactive community. They were probably bringing up a lot saying, hey, we have these observables, but you can't test them because they're always on different threads. We can force them on a new thread, but that just breaks the flow. So we want a test method. So they gave it to us, and it's great. Another big thing about RxJava 2, and this is something that annoys me, is it does not pass nulls. If you have a null object, it will throw an error of null pointer exception. In RxJava 1, you can kind of get away with it as long as you're keeping track of that you do have nulls. Here's kind of just, again, from the wiki of why you can't do it anymore. Some of the annoyances is if you use a retrofit, you might know that you can do a call and you can pass in a void object because maybe your API has no content. It's just a 200 post call or whatever. You can no longer do that. Now you have to wrap it around the response body object and then just never pass a null through it. Just keep it in its object and you can use it. Keep calm, this is only the beginning. RxJava is a massive library with a lot of resources, a great community. In fact, I've tried to grab some of the more important resources I found. The first one is just direct to the RxJava website. RxAndroid is just the one that does some more friendlier stuff for Android. The RxBinding is the RxJava for views. That was the one I was talking about for like text views and on-click listeners if you want to go that route. The next one is a beautiful website that'll have picture diagrams of how every single method works, every single method you can call, how to use them. It's probably the best documentation I've ever seen of any API. The Rx resources, again, is just a community collection of just resources found over time, people who've worked with RxJava and realized going in, oh, I could do this, and then realizing as time went on, oh, this is actually the correct way, or these are some of the nuances I've discovered as going on. And then the last one is just the differences in 2.0 for people who are familiar with 1.0 and want to see what those changes are.
So with some of these libraries that are out there, they have a problem right now working with 2.0?
Nope. So the main ones I use are all done by Jake Warren. He's been pretty much a big component for RxJava 2. In fact, he's got his libraries done since RC1 because he's just been like, yes, this is what I've been looking for. This fixes so many issues. So, and Right now, there are two separate libraries, so you can still use RxJava 1 if you prefer, or you can switch to 2. All libraries support both. RxJava 2's file path or the import path is different for the observables. So instead of like RxJava, it's reactive.o or something like that. So you do have observables, but now they're pointing to different observables, so you don't have to worry about any code overlapping. And that is it. If you guys want to see any examples or see any methods or how it's done, let me know. I can type them up right now.
Yeah.
All right, what would you guys like to see?
Let's see that edit text example that you were talking about previously.
Okay, hold on, I need to grab this library. So here's the RxBinding, again by Jake Wharton. Let's see here. I want this one. Okay. By the way, if you're ever using RxAndroid, make sure you have RxJava. RxJava is in RxAndroid, but he doesn't always update it to the latest and greatest, so it's nice just to compile it yourself as well. Okay, so that should be good now. So all you have to do is you just say RxView dot, and then it was, so we have the click one where let's say I pass in some view. I'm just going to say new view just so I can get through this. And then you'd say subscribe, new action. That's it. So now you have a subscription to this where you can say, hey, when I get a click, go ahead and do something. But now let's say you want to get fancy with it, and when the user clicks on it, maybe you want to say map, oops, I have too many dots, map, new, and again, this is all pre-populated as you can see. I'm literally just typing it as it goes. So I think the RxBinding is still RxJava 1, but that's fine. So here, let's say, you know, maybe I want to log dot I. And subscribe. There. So maybe you want some analytics here. Maybe you want to do, when the user clicks, maybe you want to do an API call. You have so many options, it's almost too many options. And you still can just have this ultimate end call. In fact, I can even say, when the user clicks, I want it to return maybe a string. Change to string. So perhaps I don't even care about the click. I just want the, whatever the final outcome could be. Maybe it's a string. So you can say, other options are like, if you have a click, you can do .FlatMap to have retrofit. Maybe you go grab the login, or maybe he wants to show pictures. You can flat map that in, and then you can just have this entire workflow all contained, and you can just kind of pass it through your stream. So if you ever want to change anything, so say, okay, this hello world gets passed in, but you know, my boss, he wants it to be something else. He wants it to be maybe an actual object. You can then actually edit the flow. Say maybe I want to do flat map, new, observable. The question mark you just have to replace with what your ultimate object is going to be at the end. We're going to say this is going to be an integer. if I can spell. There we go. So now I can just return observable, no, dot just, and then we'll pass my favorite number. And again, this is with FlatMap, so you have maybe again you want to do 100 API calls or whatever or maybe you have a whole bunch of routines you want to run. You can go ahead and use FlatMap, and you can just say, hey, these are the observables I want you to run. Here's the data, and go ahead and just send it out. And I just got to make sure to change this back into integer. You just got to make sure whatever your last action is matches your subscribe. Otherwise, as you can see, it does kind of yell at you for not pushing out the right object.
Can you describe what's the difference between map and FlatMap just quickly? Like how do you decide which one to use?
So map is a one-to-one, so you do an action and you're done. A flat map, it expects an observable, so say maybe I want to write this a little bit cleaner because we all love functional programming. I can say observable inner, give me my value. There you are. Integer, grab some number, string API input, observable dot just API input dot FlatMap new. By the way, if you have since this is expecting an integer to be returned, if you want to be a little bit lazy, you can just type return in the front, and then when you do the auto populate, I guess it doesn't work anymore. It used to auto populate because it knows it was expecting an integer as the final result. Integer. By the way, this is much harder typing up with my head on the side and keyboard in front of me. And then comma. So now you can totally put this observable in its own method, so it's completely clean, so it's not being this long, disgusting mess of what is going on. And now you can just say, hey, I have this string, and I want, oops. Observable S, and there you go. So now you have a separate workflow right here where you just say, hey, I told this guy I don't care the order, but here's some observables every time I get an input for string of how to handle it. And now you have full control over this observable flow on its own. And you can do this as many times as you like. You can put all your code in one. As you use RxJava, you can realize you don't want to do that. It becomes this giant mess. It's better just to keep things kind of separated in their own methods, because then as you need, maybe requirements get changed, all you have to do is you go to that one method, change what you need to change, and now the entire workflow is up to date and is following the correct requirements. You never have to worry about fishing through code and be like, okay, I made this API change, what else is going to break because of it? This keeps everything in a nice stream where you change one thing and the stream keeps going.
And what threads are, what's the call running on, for example? And then, yeah.
So this guy is probably going to be running on the new thread, just because it's a click listener, but I can tell it right before the subscribe to say, hey, I want you to subscribe on, and then you just say schedulers dot, maybe that's not the right one.
Scheduler instead of schedulers.
Yep. Gotta love the plurals. And then there you go. You get all your choices of what you would like to use. So you can put on commutation. If you want to make your own custom thread, maybe you want to pass in your own runnable because you want to be that tight of a control. You have all that to your disposal. Immediate means it will run instantly. It becomes from an async to a sync. So if you ever want to run something that just needs to be done now, but you want to keep your flow, you just tell it to subscribe on the immediate.
Yeah, I
Yep.
calls or writing I/O anywhere.
Yep.
Um,
Computation's great if you want to do like iterations, for loops, or anything that just requires like heavy processing power. And then you thread, I mean, you can do whatever you want in that.
Is there any kind of like syntactic shitter for making sure things are calling back on the Android UI thread within like maybe some sort of Android extensions for RxJava?
Yep, all you have to do is you just say observe on Android schedulers dot main thread. And now you're Android safe. But your work will still be done on the IO thread. It just gives Android the ability to communicate with that observable to say, hey, work is being done on the IO thread, but I need to do some UI changes.
Right.
And it's as simple as that. You never have to worry about wrapping all your code in, run on the UI thread, wrappable everywhere. You just put it once, and now your entire flow is golden. And this is just me being picky, but I like keeping things in a line. Sometimes I'll keep the formatting correct. Sometimes Android Studio just doesn't like me. Any other example?
What is life cycle of, it just like, is it according to the application life cycle or?
So you have full control. That's actually a great question. So this object will return a subscription, which is just a simple as, I'm going to put it up here. Subscription. Subscribe, there you are. Subscription. And this is where we start getting a little bit more advanced, but you can say, hey, I'm subscribing to this, but I want to keep track of my subscription object. So let's say the user might want a background on the app, and you don't want an IO call to be made because the Android's going to be like, oh, the app's not running, you can't do that. So you can have the subscription object, and then you can go into your insert, there's override on pause, and say, hey, I have if subscription dot, it's not unsubscribed. And that's all you have to say. So now your subscription has been unsubscribed and the work will stop.
And when the activity is destroyed, what happens if I'm not explicitly telling it to do something?
If the activity is destroyed and it's running something, you do have to make sure you tell it to unsubscribe before it's done. Yep.
Okay.
So you'll see in a lot of examples, people will, you can either put this code on the on pause, or people sometimes put it on the on destroy. I prefer on pause just because it's a better guarantee of it being called, and you also have more control. So say maybe the user backgrounds the app, you can pause it, and then all you have to do is just you resubscribe to your call, and then you're back on track.
Let's say I'm making a network call and the
Mhm.
user rotates the phone. So at that point in time, I'm going to want to unsubscribe.
Mm-hmm.
Is there like a built-in, or is there a library with a loader or something like that so I can pass my my subscription through and like reattach to it later or something like that?
You can just do, so instead of saying, I want to subscribe here, we're going to get rid of this. So this returns back a observable of integer type, so observable integer. So you can have this observable where you kind of control this workflow, and you can turn into a hot object, which is dot. Oh man, I wasn't expecting tough questions tonight. Hold on one moment. So this is where we get to the next level, where you start dealing with like publishers and hot and cold subscribers, where you can basically say, hey, turn this observable into a hot observable, or turn it into an observable where do all the work, but as soon as someone subscribes, give me the latest and greatest from that work. Let's see. Here we go. So
Hot and cold begins if it's cold, and if no one's listening, no one's pulling.
it doesn't do any work. And hot says, I'm going to do work regardless of who's listening. And then as soon as someone subscribes to a hot object, you get whatever the latest output was. So let's say you have a hot object, it spits out 3 items, someone subscribes, he gets that object, and then say it spits another 3 objects, whoever then subscribes at that point gets the next latest, while the person who still subscribed has been getting those data points. So publish subject is a great one where, again, here's their API kind of showing you how things work. So subjects are an interesting topic because it's both a observable and subscriber, so you can do a 2-way communication. And here's kind of the example where you can tell it to sort of like pause or only grab information as it requires it. Let's see here. In RxJava 2, and this is something I'm still learning because this is pretty new. Where is it? Action subscribers. Oh, where'd it go? I know it's in here. Here we go. No, okay, I was wrong. Here we go. So here's kind of like the RxJava 2, where you also get these resource subscribers. You also can get a hot subscriber where you can kind of have the control of it, and then you just kind of just tell it dispose whenever you want it to, or you can subscribe to it as this guy did here. But as you notice here, he has complete control of his subscription, but maybe he's not doing work until here, but then he has control of disposing it. Another thing you'll notice in RxJava 1 to 2 is unsubscribe has been renamed to dispose. So if you see any of those unsubscribes, it's probably still RxJava 1. So be familiar with the new terminology dispose. And if you ever go, this is the difference wiki, you can just go to RxJava. You will see they do really good documentation as well as tell you exactly what has changed. Because this is annoying when people don't tell you what has changed and what hasn't. So they've done a good job. So for example, from async, which was one of my favorites, that was in RxJava 1, has been renamed to the correct .create. So this is what we used to use if we wanted to do something that maybe, let's say we're using some sort of SDK that has some async calls, but we want to keep everything in RxJava. You can say .from async, and now you can wrap around their API so you keep your flow and the rest of your app works as intended versus using their interfaces and expecting these callbacks that may or may not give you data. Another object, since I have this page open, is the maybe object. So let's say you have something that might return something or might not return something. You can just use maybe. So this is a great one for testing, where you can say, here's an object, and you might get something as an output, or you might not get something as an output. And this object will handle it perfectly fine for you. So here's a good one where they show you testing where they just do some simple stuff, and then they just assert if it comes out.
Is this another alternative if you were expecting a potential null result as well?
No, so you can't use any nulls even with the maybe call, just because they've implemented the null pointer exception, where if they find any nulls at any point, even if you are prepared to get the null because it's a valid output, RxJava 2 is saying no, you cannot do that anymore. And one thing you'll see here is .filter. This is a really powerful call that gives you a lot of flexibility. So say we get this string object, and I want to do dot filter new function. I can say, okay, if this string is equal to, let's say ignore case, hello world, go ahead and pass it. If it doesn't meet this filter check, it will not, yep. So if you have any data, let's say you make an API call and there's some bad data in there, you can filter it right out. You never have to worry about it. Likewise, there's also Flowable from, actually we'll just say, yeah, from iterable new array list, some object. That's not gonna let me do that. String. So say you have, you're iterating through a list, you're getting a bunch of data, you have your maps called to change the things as it comes in, you filter out things you don't want, and let's say, okay, I got all the information, it's nice and clean and pretty, but I want a list. You can now just say dot to list, and it'll spit out a list for you of that object type. So let's say, again, if you're making maybe a JSON call where you are getting an array back, you want to iterate it, you want to make sure it gets converted into your Java objects, you want to clean it up, and now let's say, oh, I just want this all in a list so I can just manage it throughout my app, just say to list, and now you have it in a list of that object type. Any other examples?
So quick question, would you use this in conjunction with Java 8 streams, or completely separate from, or is there ever a reason to mix and match those?
I would use them separate. If you ever want to say you don't want to use retrofit and you want to use your own HTTP client, you can just say flowable.create new, we'll say string will be our output. Implement. Why are you yelling at me? Oh. If you don't apply pressure to the flowable object, it will yell at you. But here are some of the ones. As you see, there's buffer, drop, error, latest, and missing. And buffer is usually the go-to. So now I can just say HTTP client. Okay. Well, I don't have it at this moment, but I usually use OK HTTP client. Now we'll say client equals new. Client. Do some work. Maybe you want to set up your client to have specific headers or whatever. Maybe you want to make sure it has the right parameters and all that, but eventually you can just say client dot, I think it was like response or something along the lines where you can just say, okay, everything's set up, make my API call and grab the data. Well, since this is an async task, you can say dot e, which is our emitter, on next, and then the response. And then if you know that is your only call that you're going to do, you can then just say emitter dot onComplete, and you're done. There's no extra work, there's no heavy lifting. If you pair this with retrofit, it's even easier. You make your retrofit interfaces, and then all you have to do is say, hey, I want you to return an observable, and you're done. There's no extra work. Right now, they have an adapter to support RxJava for retrofit 2. RxJava 2, you have to go to Jake Wharton's off branch because they haven't officially released the adapter yet.
So when do you use observable and when do you use flowable?
I recommend just use Flowable for RxJava 2 moving forward because observable, like I said, doesn't implement any back pressure. So if you have anything that will spit out faster than the subscriber can read, it's going to error out saying, hey, we got an overflow of data and we can't move forward. Whereas Flowable, you can tell it how you want it to handle that back pressure so you can move forward. So if it does get built up, you can either throw it out, you can just say, hey, just buffer it out, I'll get it to eventually, or you can just have it aired out completely. Any other examples?
In terms of energy consumption or just
it's a million times faster, and then it's almost no load from what I've seen. Like the people behind Reactive have done a fabulous job. They've have a lot of top experts all working behind the scenes to make it so for us developers it's seamless and it's lightweight. So if you have any network calls or anything like that, you can even like watch the CPU in the network flow, and you'll notice it spikes a little, but then you run an async task and it's almost twice as big.
How about along those lines, like gotchas around, like you forget to do something and now you're leaking some sort of observable thing, and so you got memory problems or something. Is there any kind of thing that's caught you up in the past with RxJava 2?
I've never had a memory leak with RxJava. The only time I can think of it is if you maybe pass in like a static context, because we all love to do that, and then you don't dispose of it correctly, you might get leaked through there. But RxJava itself, I've yet to see a leak. On the repository, there's a few bugs of some people finding leaks, but what they're doing is just beyond what you would probably expect to do normally. Mm-hmm.
So let's say I have a list of data and I want to make a network call for everything individually in the list at the same time, and then react to the completion.
Oh, yeah, that's one of my favorite ones to do. So I'm going to clean some of this up. So let's say I have a Flowable dot from iterable new array list of, so let me do that. But I'm going to say string because I don't want it to yell at me later. So say I have maybe a list of like APIs or something I want to call, or maybe these strings are the key to the API. I can then say from here dot FlatMap new function. Again, you can say whatever your object wants to be, but we're just going to say string private observable global / string make API call string key turn just key dot we can say dot. No, let's do this. Dot create new. Yeah, you want me to implement the back pressure, buffer. What? Give me on next, not complete. There we go. HTTP client response dot e dot on complete. Do you want it to be in a list in the end, or do you just want it to spit out every object it gets as it gets it?
Let's bring them back all together so that we can respond when we're complete.
Okay, so we're going to say toList dot subscribe not on dot subscribe new, and here I'll show you the consumer so you guys can see what that's all about. And there you go. So now I'm going to say, okay, go through my list of keys. I want you to go ahead and make the API call. So here you can create your own. You can just retrofit whatever you prefer. You just say, hey, here's the key. Do the response. Maybe you put in the URL and all that. And as you get the response, go ahead and spit it out. And then as it spits it out, it's going to make this list, and it's going to just start adding it. And once everyone is done making their calls, you will get this beautiful list of your results. And then you can do whatever you like from this point forward. But
So you'd still have to subscribe on IO thread or something like that, right?
So you would do that probably, if you want to keep things nice and tidy, I would say do it here, because you know that this is definitely going to be doing a network call. Schedule.io. And then that's it. Now it's on the IO thread and you never have to worry about it again.
And how it would, if you wanted to do it one by one, you know,
What do you mean by, oh, if you want to see the results one by one? So all I have to do is just get rid of this to list and just subscribe. Yep, and then you just say subscribe, new. I did need to. There we go. And then you'll see here you have a few things. So the consumer is the one you'll probably use more often than not. The ones I used to use are, I think it's subscriber, where it will return the on next, on complete, and on error. And all on complete is saying all the work in the entire flow is done, and this is the on complete call. Whereas the on error is at any point you get an error, it is a terminal call, so it stops the entire stream and gives you that error. So if I do, let's say, new consumer string, but I also want to get what that error is, you just say comma, new consumer, and you'll see the type is now throwable, and there's your throwable. So at any point, if you get any kind of error, you will get it at this accept throwable call. And if you use the subscriber object instead, it'll be on error instead of accept.
And so the first accept will give us every single emission.
Yep, so every time it gets an object, it'll spit out whatever your ultimate object is going to be.
And then do we add a third consumer param to get the on complete?
Yep, so after the on error, again, you just do comma, new, action, and then there you go. This is your on complete, I'm done, there's nothing left to do. Go ahead and terminate. But if you're going to use all three, just to keep things clean and tidy, I would just say use a subscriber, and then you get all the objects. And then if you want to mess around with the actual subscription when it gets subscribed, you have that ability right up here. And here's the RxJava 2 path. Whereas RxJava 1 will still use, I believe it is this one right here. Oh no, here it is. Dot. It's just Rx. So they kept it clean. So in RxJava 2, that since they reuse a lot of the same object names, that you have your own separate paths. So you don't have to worry about code all of a sudden just breaking for no good reason. All right, any other examples?
So when not to use React?
When not to? So like any great tool, it's very easy to abuse it, maybe overuse it sometimes. It really just depends on what you're trying to accomplish. If it's simple and doesn't require a huge flow, perhaps just do it the old-fashioned way. If you want to keep the control flow, so maybe let's say you have changing requirements, or it's just doing a lot, or maybe a lot of people are looking for that information, RxJava is very good at that. If you're familiar with the Netflix app, that is completely RxJava. So what they're doing is they're making all the calls and then they're subscribing it to their activities. That way, as they get information, they shoot it out to their adapters who are probably listening, and they update things on the fly. So like all those images are done on the fly, and literally RxJava is saying, oh, hey, here's an image, and it populates it immediately.
Do you have any recommendation for like a book, a course, or something that, because this is a lot to learn.
Oh,
like,
yeah.
How did you learn RxJava?
Google.
Like RxJava.
Yeah, so my old boss, Michael Cameron, he actually introduced RxJava to me a year and a half ago. And man, what a struggle. Him and I pretty much bumped heads for like the first 2 weeks because RxJava is such a unique pattern. where you're used to all these async, you're used to making all these separate calls, and then RxJava comes and say, nope, we're done with that, we're having clean streams, and you kind of have to like switch your brain to that flow. Otherwise, you're gonna try to do things where it's like, oh, I'm doing all this and it's not working. It's like, well, are you in the stream? A lot of good resources if you go. The biggest one I would say, let me see if I have, where's that PowerPoint? Is it over here? Oh, my PowerPoint's gone. Here, let me grab that really quick. Oh, here it is. The biggest resource I would definitely say is this one, because this is their literal API, fully documented with all the graphs of how every observable works. Let's see if I can find a good one.
But you probably don't want to just go through them one by one and learn them all. Like, this is a huge
Oh,
list.
yeah. This collection's a pretty good one to go through. Here you'll see like there's some introduction courses. They go over how to code in more depth than I will in this course, just because this is more of an introduction to RxJava. They will go through, they have examples, they have operators, I mean, they have Android specific stuff, and then you start getting to some really heavy courses. The Android wiki, or the Android Reddit thread has also been pretty good. A lot of people post Rx findings there as well. Pretty much just Google Android RxJava and you'll find examples of the wazoo now these days. When I first started, there weren't any examples, so it was definitely just playing with it, just trying out all the calls, seeing what they do, and just messing around. And then as you use it more and more, it does become familiar. It is a little bit rough on the edges when you first start off, just because it is a lot of new information. It's a whole new workflow. But once it clicks, it's a whole new world for Android.
Just to note, there's Rx libraries for lots of languages.
Yep.
JavaScript, Swift, .NET.
Yep. So RxJava is just the one for Java specifically, but there is one for like C#. I think iOS has its own reactive library as well. So this isn't just like only for Android, only for Java. You have it for multiple platforms. Any other examples you guys want to see while I'm still here?
What would say the three patterns you use the most? You said I guess you use just all the time.
For the most part, .just and .from the elaboratable are my favorite ones to use, just because you'll be surprised how often you'll use it. .zip is also another one. Learning that you can make your observables in methods is a huge help. When I first started, all this code would have been up here, and it will just be this massive.
Indent.
Yep.
Hell.
Yep. And like you would see people literally go from here, and they'll say like, oh, I want to also do a .FlatMap here. I kid you not. And then they'll do another .flat, and it becomes this chain where like you lose the RxJava flow of like keeping it nice and clean in one level to this like, oh my God, why is there 100 FlatMap calls in one method? So using methods are a great way to keep things clean. It also makes it very easy for unit testing, because now I can go ahead and just say, hey, I want to test this in my unit test and make sure it's spitting out correctly. So you can test each individual component, and then if you know in your unit test every component's working, your whole stream is golden. If any of your, maybe your PM or something comes by, like, all the apps broken, you're like, nope, unit tests say it's working just fine. So you can blame the backend guys at that point. Anything else? I know this is a lot to consume. I highly recommend just taking the time, going home, make a sample project. The big ones you want to grab are these two, and just play with it. Really, you'll learn. It's a lot easier than it looks. It's just scary and terrifying at first, because it is a brand new library and people are still kind of learning it and still getting familiar with it.
All right. Well, thank you.
Thank you for having me.